the greatest, ain't no.
So alkenes are carbon chains with at least one double bond. And you probably remember that the simplest alkane is methane. The second simplest alkane is a two-carbon chain called ethane. Well, alkenes actually are pretty simple to name. We drop the ane suffix that we used with the alkane and replace it with ene. So ethane becomes ethene. So anytime there is at least one double bond present in the molecule, the suffix will become ene. Double bonds are very reactive. And you might remember when we were making addition polymers that all of those monomers had at least one double bond. So ethene is used as a monomer or a base material for no-stick cookware, and it's also used for polyvinyl chloride or PVC. This is an example of a conjugated diene or a conjugated alkene. And you might remember we recently talked about these when we were synthesizing fabric dyes, because chromophores oftentimes are conjugated alkenes. They have an alternating pattern of double, single chemical bonds. So, naming this simple alkene, first of all, we're going to use numbers to locate the double bond. So the first thing we should probably do, or always do, is number the carbon chain. So we're going to indicate in the name the very first carbon where the double bond starts in each case. So our double bond starts at carbon 1 and at carbon 3. So we would start naming this alkene as 1,3. Then there are 4 carbons present, so this is a buta. There are 2 double bonds, so we would use the prefix di, and the fact that they are double bonds, we end with the suffix ene. So A tells us that we're going to locate the double bonds with numbers in the chain. B is the prefix for the number of carbon atoms in the chain. Propa, buta, penta, hexa. C is a prefix that tells us how many double bonds are present in the molecule. And then last of all, we change the suffix to ene. So this would be 1,3-butadiene. Alkynes are carbon chains with at least one triple bond. And these have been historically really important and are still important. Welders use acetylene as a fuel, which is an alkyne. And the very first effective birth control pill was an alkyne. In the skeletal notation, a triple bond is represented as 3 parallel lines. Some acrylic paints are alkynes. Alkynes are named much in the same way that alkenes are named. So again, we number the carbon chain. And we use numbers to indicate where the triple bonds begin in the form. Benzene is another really important molecule in organic chemistry. Benzene represents a class of compounds that are called aromatics because historically the first compounds had very pronounced fragrances and odors or aromas. So in the benzene molecule, the electrons are spread out over the top of the ring and the bottom of the ring. Typically in a chemical bond, the electrons are restricted to a region of space between the two bonding atoms. Not so in the benzene molecule. The electrons are free to move around that entire region of space above and below the plane of the molecule. That gives benzene some interesting and important chemical properties. So if we were to name this simple aromatic compound using the IUPAC system, again, we would number the ring. And we would number so that substituents have the lowest possible number. And then we would use the numbers to locate the substituents on the benzene ring. So this molecule would be called 1,2-dichlorobenzene. What do you think this molecule would be called? Well, we would number the benzene ring as before, and we would then name the substituents alphabetically. C comes before M, so this would be 1-chloro, 3-methyl benzene. Commonly, there are prefixes that are used with these simple aromatic compounds that tell us where the substituents are positioned on the ring. If the substituents are right next to each other, as they are in this case, the prefix ortho is used. So we would call this compound ortho-dichlorobenzene, or sometimes for short, O-dichlorobenzene. The prefix meta is used when there is a carbon between the two substituents. So we would call this compound meta-dichlorobenzene, or again for short, M-dichlorobenzene. Then last of all, when the substituents are opposite of each other on the benzene ring, we use the prefix para. So this molecule would be para-dichlorobenzene, or for short, P-dichlorobenzene. So, what would the common name be for this molecule? If you said ortho-dibromobenzene, you are right. This is another commonly used solvent in organic chemistry, and it's called xylene. Xylene consists of two methyl groups that are attached to a benzene ring. So this would happen to be para-xylene. Another very common molecule in organic chemistry is the benzene ring attached to a nitrogen atom or to an amine, and this molecule is called aniline. It's used in the synthesis of Tylenol. It's used to make indigo. In fact, we used it when we made the dye indigo. It's also used to prepare insecticides and other products. A benzene ring with a methyl substituent is called toluene. Toluene is used as paint thinner, and it's used to make TNT. Another very common molecule in organic chemistry, and we will use this molecule to prepare a product using the Friedel-Crafts alkylation reaction, is phenol. So a benzene ring with an OH molecule attached. And phenol is present in Sucrets, which is a medication that relieves a sore throat, and it's used to make a variety of other consumer products. All right, let's finish with a review problem. So using the IUPAC nomenclature system, see if you can name this molecule. Well, I would start by numbering the carbon chain. Next, I would place the substituent with a number. So we'll start with 1 bromo. Then notice that we have 3 double bonds. The double bonds start at carbon 1, carbon 3, and carbon 5. So 1 bromo, 1, 3, 5, and there are 6 carbons in this chain, so hexa, 3 double bonds, tri, E.
You baby, my sugar boo.